let's take a look at question number 3. It says, what type of haloalkane, primary, secondary, or tertiary, is the best one to use as a reagent for the SN2 reaction? What about for the SN1 reaction? And you must provide a detailed explanation. So let's take a look at this question. Before we get to the answer, let's just double check that you understand what a primary haloalkane looks like versus a secondary versus a tertiary. This haloalkane is primary because the carbon that is directly attached to the halogen is just attached to one carbon. What about this one? This one is a secondary haloalkane because the carbon that is directly attached to the halogen is only attached to two carbons. What about this one? This one is a tertiary because the carbon that has the halogen is attached to how many carbons? 1, 2, and 3. Okay, so let's go back to the mechanism of the SN2 reaction. For the SN2 reaction, you have to remember that you have a backside attack of the nucleophile to the substitution center, to the carbon that has the halogen. The halogen is your leaving group in this case. So it goes away, let's say, in this direction to the right, and then from the opposite side, the nucleophile is attacking. And all of this happens at the same time. So what we want is, we don't want this carbon to be crowded. We want the nucleophile to have easy access to this carbon. So if you have a tertiary haloalkane, then you have this group that they are crowding the substitution center, this carbon. So for SN2 reactions, we do not want tertiary haloalkanes. What we want is a primary haloalkane as a reagent due to steric. So let's take a look at the SN1 reaction. For the SN1 reactions, you have to remember that you've had the formation of a carbocation in the rate determining step. So when you have a carbocation, you have to remember from chapter 6 that a tertiary carbocation is more stable than a secondary, and a secondary is more stable than a primary carbocation. Meaning, the more stable the carbocation, then the faster the SN1 reaction. And also, the tertiary haloalkanes are protected against backside attack. And the backside attack is what happens in the SN2 reaction. So, in summary, you want a primary haloalkane for SN2 reaction, and tertiary haloalkanes, they work best for SN1 reactions. When you have a secondary haloalkane, but then you have to consider other factors to see if the reaction that will be SN1 or SN2, the nucleophilic substitution reaction.